Good morning, class. Today we are going to study about one of the important properties which has been mainly asked in class 10th. This property is periodic property. This topic is been related to our chapter number 5, that's our periodic table. So guys, today we are going to have an idea about this term periodic property. Periodic property is what? It is a property of elements. These properties are being related to electronic configuration or to the atomic structure. That means the properties of element which are being explained by electronic configuration or which can be correlated with electronic configuration or the atomic structure as said to be the periodic property. Now the first property is valency. Valency is defined as combining capacity of an element. So guys, how come the definition combining capacity of an element is being given to the term valency? For this, we are going to have an example, that's aluminium chloride. Guys, we know that aluminium is symbolically represented by Al and chloride is symbolically represented by Cl. The valency of Al is 3 plus 3 as it is a metal and Cl is minus 1. So when we cross multiply these two, the Cl will be multiplied by 3 and Al will be multiplied by 1. So we will be getting AlCl3. That means when one atom of Al combines with 3 atoms of Cl, it results in formation of AlCl3, that's our aluminium chloride. So here comes, we came to know about the definition of valency, that is how many atoms of Al should combine with Cl to form aluminium chloride. Hence, it has been stated combining capacity of element is its valency. Now, the question arrives how we are going to calculate valency. The valency is being calculated by valence electron. Students, when the valence electron ranges from 1 to 4, itself becomes the valency of those elements. But if the valence electrons are more than 4 in number, then to calculate valency, we will be doing what? We will be subtracting the valence electron from 8. And after subtracting this valence electron from 8, we will be getting its valency. It will be further more clear when we will be dealing with the examples. Okay. Further, we should know that when an element is having 1, 2 and 3 valence electron, they do have tendency to donate electron and are said to be cations, symbolically represented by positive sign. That's why Al being metal do carry positive ion, as we know that all the cations are our metals. Meanwhile, if an element do have electrons more than 4 in number, that is it ranges from 5 to 8, 5 to 7, they do have tendency to gain electron and are said to be anions, represented by negative charge and are non-metallic in nature. Meanwhile, if an element is having 4 valence electron, they don't have the tendency either to donate or to gain. Rather, they do have tendency to share electrons, and in later chapter we will came to know about this. Because of this behavior, these elements do form covalent compounds. Okay guys, to the third question, which we should know that how the valency do vary in a group. Students, firstly we should know that as in a group, for considering its variation, we should take a group. Right now I had taken the first group. If I'm going to write the elements of first group, that is hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Say as if I don't have any idea about the atomic number of the later element, I do have only idea about the first element's atomic number. So how come I came to know the atomic number of the rest one? The procedure is, you should have to add 2 to the first element and you will get the atomic number of the second one. That is, when I add 1 to this 2, I will be getting 3. Hence, the atomic number of lithium comes out to be 3. Now, when I'm adding this 3 to 8, I will be getting 11, which is atomic number of sodium. Again, when 11 is added to 8, I'm getting 19, which is atomic number of potassium. When this potassium is being added with 18, I will be getting 37, atomic number of rubidium. 37 when added with 18, I will be getting 55, atomic number of cesium. 55 when added to 32, I will be getting 81, which is atomic number of francium. That is, if I'm knowing the atomic number of the first element which belongs to our first period, how am I going to calculate the atomic number of rest? By adding 2, 8, 8, 18, 18 and 32. By knowing these atomic number, I am writing the electronic configuration over here. But when we analyze the electronic configuration, we came to know that these element of group first is having 1, 1, 1, 1, 1, 1 and 1 electron in its valence shell. As we can say that the valence electrons are same, so they do have the same valency, which is being said to be +1 for group 1. As we had studied over here, if an element do have 1 electron in its valence shell, do donate its electron will become cation. So I had written +1 plus over here, and as it is donating 1 electron, so the valency comes out to be 1. In some of the works, they are not mentioning the plus sign over here, that is, they are not focusing on cation over here, but we can say that in that condition too, we can say that the valency is said to be 1 only. Now, how the valency is being varying when we are moving from left to right in our period. Okay guys, for this I am having an example. The example belongs to our group second, that is the second group to carry the elements hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. In the second series, I had written the atomic number of these elements, which are 3, 4, 5, 6 and then still 10. Now in the third, I had written the electronic configuration. Electronic configuration of atomic number 3 can be written as 2, 1, 4 can be written as 2, 2 and as we proceed it ends till 2, 8. So what am I seeing over here? As lithium is having 1 electron in its valence shell, so the valency become 1. Right now students, I am not focusing on the plus and minus sign. I am just calculating the valency. Beryllium do carry 2 electron in its valence shell, so the valency comes out 2. Boron is having 3 electrons in its valence shell, so the valency comes out 3. Carbon is having 4 electrons in its valence shell, so the valency becomes 4. As I already told you that if the valence electron are more than 4 in number, then for calculating the valency, we will subtract the valence electron from 8. Here the nitrogen is having 5 electrons in its valence shell, so to calculate its valency, I had subtracted this 5 from 8, so the value comes out to be 3. Then for oxygen, as the valence electron are 6, so the valency is 8 minus 6, that's 2. Fluorine valency comes out to be 1 as we are subtracting the 7 from 8. Neon, as it do have 8 electrons in its valence shell, so the valency comes out to be 8 minus 8, that's 0. So guys, what we are saying, the valency is first increasing till 4 and then again valency is decreasing till 0 as when we proceed from left to right in our in a period. For further properties of periodic table, we will be having another class in which we will be dealing other periodic properties of the elements.